Hi class. What I want to do in this lecture is talk about simplifying variable expressions. Okay, so we're going to have 5 objectives we're going to talk about in this section. First one is we're going to talk about the properties of real numbers. And basically what the properties are they're just ways you can simplify and work through problems. And we're going to use those properties later when we get into the following objectives, which are simplifying variable expressions using the properties of addition, simplifying variable expressions using the properties of multiplication, next simplifying variable expression using the distributive property, and then finally when we talk about simplifying general variable expressions. And all this last part is we're going to put to use all the properties above in just one general problem. Okay, so let's go through the properties of real numbers, and I'm going to go through them really quickly, and I'm going to provide an example of each for you. Okay, so the properties of real numbers describe the way operations on numbers can be performed. So what I have here are some properties of real numbers described algebraically and then in words, and then what I'm going to do, as I said, was provide an example of each. Okay. Okay, so the first one we have is the cumulative property of addition. So if a and b are real numbers, then if you have a plus b, it turns out it's the same thing as b plus a. So two terms can be added in either order, and it doesn't matter, the sum is the same. For example, 4 plus 3 is 7, which is literally the same as 3 plus 4 is 7. So it doesn't matter, you can add them in either order. So the cumulative property of multiplication, so if a and b are real numbers, then it turns out if you have a times b, it's the same thing as b times a. So two factors can be multiplied in either order, and it turns out the product is the same. So for example, if you have 5 times negative 2, that's going to be 10, but guess what? That's the same thing as negative 2 times 5. That will also be negative 10. So you can multiply in either order in this case. All right, now let's talk about the associative property of addition. If a, b, and c are real numbers, then if you have in parentheses a plus b and then add c to that, it turns out it's the same thing as a plus in parentheses b plus c. So when 3 or more terms are added, you're adding them, okay? The terms can be grouped with parentheses, for example, in any order, and it doesn't matter, the sum is the same. So if you look at my examples down here, if you take 2 plus and in parentheses 3 plus 4, 3 plus 4 is 7, plus 2, that gets you 9. And it's the same thing over here if instead you group the first two, 2 plus 3, and then add 4. 2 plus 3 is 5, plus 4 also gets you 9. So you can group them in any order, doesn't matter. Then we have the associative property of multiplication. Basically, it's the same idea. If a, b, and c are real numbers, then a times b in parentheses times c turns out it's the same thing as a times b times c in parentheses. So when 3 or more factors are multiplied, the factors can be grouped in any order, and it turns out the product is the same. So if you look here, in parentheses 3 times 4 and then times 5, well, 3 times 4, negative 3 times 4 is negative 12. Negative 12 times 5 gets me negative 60. But suppose instead you wanted to group 4 times 5 and then multiply it by negative 3. Excuse me. Well, 4 times 5 is 20. 20 times negative 3 also gets you negative 60. So it doesn't matter. You can do it in any order here. Next, we have the addition property of 0. So if a is a real number, then a plus 0 is just a, and it's the same thing as 0 plus a. It's still a. So the sum of a term and 0, whenever you add 0 to something, it's just the original term. Like, for example, 4 plus 0 is still 4, and 0 plus 4, still 4. Doesn't matter. Okay, multiplication property of 0. If a is a real number, then a times 0, anything times 0 is 0. And 0 times any value, so 0 times a is 0. So the product of a term and 0 is always 0, never changes. So 5 times 0 is 0, and 0 times 5 is 0. Doesn't change. Okay, now we have the multiplication property of 1. If a is a real number, then a times 1 is always a, and 1 times a is a. So anything times 1, so the product of a term and 1 is just the term. So for example, 6 times 1 is 6, and 1 times 6 is still 6. So that's the same thing there. All right, the inverse property here. All right, I know there's a lot, but we're getting through them. If a is a real number, then a plus a inverse or a plus negative a is 0 always. And negative a plus a is also equal to 0. So the sum of a number and its additive inverse or opposite is always 0. So for example, 8 plus negative 8 is 0, or negative 8 plus 8 also 0. Okay? Next we have the inverse property of multiplication. If a is a real number and it's not equal to 0, then a times 1 over a, so a times its inverse, okay, or its reciprocal, is always equal to 1, or 1 over a times a is also equal to 1. So the product of a number and its reciprocal is always 1. So for example, 7 times 1/7 is 1, and it's the same thing as 1/7 times 7. That's also equal to 1. All right, so just remember here, 1 over a is the reciprocal of a, and a times 1 over a is also called the multiplicative inverse of a. All right, so now let's talk about the distributive property. If a, b, and c are real numbers, then a, and then in parentheses, a plus c. Well, it turns out this is equal to, you take a, you multiply it by b, and then you add to it a times c over here. So you'll hear me say this a lot in the lectures. You distribute a to b and a to c. Or it's the same thing here. You can work backwards. B times a gets me ba, c times a gets me ca, and it's the same thing. Okay, distributing here. So by the distributive property, the terms outside the parentheses is multiplied by each term on the inside of the parentheses. So for example here, you'd go 2 times 3 plus 2 times 4. And then you would just simplify here, okay? And we're going to see you're going to get the same thing. 2 times 3 is 6, 2 times 4 is 8, 6 plus 8 is 14. If you didn't distribute, 3 plus 4 is 7, 2 times 7 gets you 14. Same thing. You'll notice it works the other way as well. 4 plus 5 is 9, 9 times 2 is 18. But if you distribute the 2 to everything, 4 times 2 plus 5 times 2, 4 times 2 is 8, 5 times 2 is 10, 8 plus 10 is 18. You get the same thing. So this distribution works. It works. All right, now let's just do a bunch of examples, okay? Let's complete the statement by using the cumulative property of multiplication. 6 times 5 is equal to what times 6? Well, 6 times 5 is the same thing as 5 times 6. Same deal. All right, let's identify the property here that justifies the statement. 2 times in parentheses 8 plus 5. Well, if you look over here, I'm saying it's 16 plus 10. Well, what I did was 2 times 8 to get me 16, 2 times 5 to get me 10. All I used here was the distributive property. All right, now let's just go through all these properties and talk about how you simplify variable expressions using the properties. So first we'll do the property of addition, okay? So the first thing you're going to do when we talk about simplifying is like terms. We want to do what's called combine all like terms. So like terms of a variable expression are terms with the same variable parts. So the terms 3x and minus 7x are like terms, okay, because they each have an x in it, okay? Constant terms are also like terms, so numbers like 4 and 9 are like terms. So if I have this, 3x plus 4 minus 7x plus 9, and then I have this minus x squared, the 3x and the minus 7x are like terms because they each have an x. It is not a like term with the x squared here because this is an x squared where these are just x's. So these are like terms, and then the 4 and 9 are like terms. So then we can combine like terms. We can use the distributive property if we want to, all right, to add the coefficients of the like terms. So like 3 and negative 7 can get combined. All right, let's do some examples here. Okay, so let's simplify the following. So first off, we have minus 2y, plus 3y, and then the second problem we have is 5x minus 11x. Okay, so let's take a look here. We have the minus 2y plus 3y. So what you can do here, all right, is you can use the distributive property. You can say, okay, these are like terms because they both have a y. So let me take out the y, and then I'm going to look at their coefficients. And I'm just going to take minus 2 plus 3 and add their coefficients. So minus 2 plus 3 is 1. And then don't forget you have the y. And then 1 times y, okay, just using the multiplication property of 1, is just y. Sometimes it's easier just to say, hey, okay, these are like terms. They each have a y. So let me just add their coefficients. Minus 2 plus 3 gets me 1, and 1y is the same as y. Let's look at this one here. So here I have 5x minus 11x. They both have an x, so they're like terms. So what I'm going to do is I'm going to add their coefficients. So 5 plus minus 11. Another way to think about this is just 5 minus 11. Well, that just gets me minus 6. And then don't forget I have the x. So this is just minus 6x. All right, let's try this one. Okay, some harder ones. I have 8x plus 3y minus 8x is my first problem. And then I have 4x squared plus 5x minus 6x squared minus 2x. All right, so let's look at this first one. 8x plus 3y minus 8x. So what you can do is you can rearrange the terms so that like terms are next to each other. So I see that the 8x and the minus 8x are like terms, so I'm going to move this over next to it. So I have 3y plus 8x minus 8x. Well, now I know that 8x and minus 8x are like terms. Well, what's 8x minus 8x? Well, that's just 0. Well, then what's 3y plus 0? That's just 3y. All right, this one here, 4x squared plus 5x minus 6x squared minus 2x. Let me rearrange the terms so like terms are next to each other. The x squared terms are like terms, so I'm going to put 4x squared minus 6x next to each other. And then I have 5x minus 2x. Well, over here, look, group them and subtract the coefficients. So 4 minus 6, that gets me minus 2, and then I have the x squared. And 5 minus 2, well, that gets me the 3. So this right here I cannot combine anymore because x squared and x are not like terms. So this is just minus 2x squared plus 3x. And we're good. Okay, let's move on and talk about simplifying variable expressions using the properties of multiplication here. All right, so the property of multiplication using simplifying variable expressions, the associated property used when multiplying 3 or more factors. So when I have 2 times 3x, this is the same thing as 2 times 3 times x. Well, 2 times 3 is 6x. All right, you can also do the order any way you want. So 3x times 2, it's the same thing. Okay, this is equal to a little bit of a typo here. 3 times 2 times x, well, 3 times 2 gets me 6x. A little bit of a typo there. All right, so by the multiplication property of 1, the product of a term and 1 is the term. So if I have 8x times 1, that's the same as 1 times 8x. Well, 1 times anything is just that whatever's left, whatever you have. So that's just 8x, okay? So the inverse property of multiplication, the product of a term and its reciprocal is 1. So if I have 5x times 1 divided by 5x, which is the same thing as 1 divided by 5x times 5x. So 1 over whatever times that same value, that's always equal to 1. And you have to note that x cannot equal 0 here because you can never divide by 0. All right, so let's work some problems. All right, we want to simplify all these. 2 times negative x, and then 3 divided by 2 times 2x divided by 3, and then 16x times 2. All right, so 2 times negative x. Well, notice that negative x is the same thing as negative 1 times x. So here I'm just going to multiply the 2 times negative 1. So 2 times negative 1 gets me negative 2. And then I'm still going to multiply by the x. So 2 times in parentheses negative x is just negative 2x. Here, this one's a little bit harder. So we have 3/2 times in parentheses 2x divided by 3. Well, the first thing you're going to note is that 2x divided by 3, what you can do is you can split this up. You could write this as 2/3 times x over 1, which is the same thing as 2/3 x. Well, then notice here, and then I have 3/2 times 2/3. These are reciprocals of each other, okay? So I'm going to move this and multiply this as 3/2 times 2/3, and my x is out here. Well, this right here, they're inverses of each other, so they're going to cancel out, and they're just going to be 1. And then 1 times x just gets me x. Okay, let's try this one here. 16x times 2. Well, you can write this as 2 times 16x. Well, now you're just going to multiply the constant by the coefficient. 2 times 16 gets me 32. And don't forget you have that x there as well. All right, so now we're going to talk about simplifying expressions using this distributive property. So what the distributive property is used for, it's used to remove parentheses from a variable expression. So an extension of the distributive property is used when an expression contains 2 or more terms. That's basically what we're using it for. Okay, so I want to simplify these. So there's a bunch of problems here. I want to simplify minus 3 and then in parentheses times 5 plus x. Then this looks weird. Then negative and then parentheses 2x minus 4. Then 2y minus 6 times 2. And then finally this one with 3 terms, 5 times 3x plus 7y minus z. Okay, so let's start with this one here. So minus 3 and then in parentheses 5 plus x. So you're going to use the distributive property by taking the minus 3 and multiplying it to everything. So you're going to go minus 3 times 5 and minus 3 times x. Well, minus 3 times 5 is minus 15 plus minus 3 times x is minus 3x. So instead of writing plus minus 3x, we just write this as minus 3x. And that's it. So this one's a little weird. Okay, this minus and then in parentheses 2x minus 4. So whenever you see a minus in front, what there really is it's minus and then there's this invisible 1. Okay, so what I'm going to do is I'm going to change this minus sign to a minus 1. And now what I have to do is I have to distribute the minus 1. So this becomes minus 1 times 2x, minus 1 times, don't forget the subtraction, minus and then 4. So minus 1 times 2x, well, that gets me minus 2x. And minus minus becomes a positive, and then positive 1 times 4 just gets me 4. Just to note, an easier way to do this problem is if you have a negative in front of a parentheses, what it does is it changes all the signs. So watch, notice how I had 2x in here. Down here it became minus 2x. I had minus 4, and down here it became plus 4. And that's it. All right, let's try this one. 2y minus 6 times 2. Well, I'm just going to distribute backwards here. Okay, so 2 times 2y minus 6 times 2 over here. Well, 2y times 2 gets me 4y, and 6 times 2 gets me 12. So this is just 4y minus 12. This one here we're just taking the 5, and 5 times in parentheses 3x plus 7y minus c. And all you're doing when you have more than 2 terms here is you're distributing the 5 to everything. So 5 times 3x plus 5 times 7y minus 5 times z. Well, 5 times 3x gets me 15x. 5 times 7y, 5 times 7 gets me 35y. And minus 5 times z is just minus 5z. And that's it right there. Okay. Let's end now by talking about simplifying general variable expressions. Okay, so when simplifying variable expressions using the distributive property, remove parentheses and brackets used as grouping symbols. So what we want to do here with this example is I want to work this crazy one here where I distribute, get rid of the parentheses, and then combine like terms. Okay, so I want to simplify 4 times x minus y minus 2 times minus 3x plus 6y. Okay, so watch how I distribute. 4 times x gets me 4x. 4 times minus y is minus 4y. Now, this negative here goes along. Whenever there's a negative, it goes with it. So remember what I said when you have a negative outside of parentheses. It's going to change all the signs. So minus 2 times minus 3, negative times a negative becomes a positive 6x. Okay, so minus 2 times minus 3x is positive 6x. And then minus 2 times positive 6y. A negative times a positive is a negative. So minus 2 times 6y gets me minus 12y. Now what we need to do is combine like terms. Well, I have the 4x plus 6x, that gets me 10x. And minus 4y minus 12y gets me minus 16y. All right, and with all these problems, class, just take your time, write the problems out, don't try to skip steps, and you should be able to solve them very easily.